righty. Good morning. The following Zoom session is being recorded and will appear later today on my YouTube channel, Math with Mayo. There are two different classes that may be observing this session. Therefore, when you participate in the Zoom meeting, if you do not wish for your picture or your name to be made public, please leave the video off and use an alias name. If you have questions during the meeting but do not wish to speak, email me at bmayo@ybcc.edu and I'll respond as soon as I can. Okay, so today we're going to go on to section 8.3, but first of all, we had a request for a problem, so we're going to do that. This is from section, hang on, wait for it, 8.2 part 2, and this is number 9. It says, write an equation for a linear function whose graph has the given characteristics, okay? It passes through the point 15, 0, and is perpendicular to the graph of g of x equals 3x plus 4. Okay, what should we know about perpendicular graphs? Their slopes are negative reciprocals or opposite reciprocals. Using slope-intercept form on g of x, the slope is 3. So the slope of the line that's perpendicular would be negative 1/3. So now we've got this slope and this point. Okay, so far? All right. So using y equals mx plus b, negative 1/3 goes in the place of m. So y equals negative 1/3 x plus b. Then we take the ordered pair 15, 0, and 15 goes in the place of x, and 0 goes in the place of y, which gives us 0 equals negative 1/3 times 15 plus b. 0 equals, this reduces down to negative 5 plus b. We're going to add 5 to both sides, so 5 equals b. So now we've got m and b. So y equals negative 1/3 x plus 5, but we're going to write it as a function. So f of x equals negative 1/3 x plus 5. So we used g of x to get its slope. Since the line we're looking for is perpendicular to that, we took the negative reciprocal of 3, which is negative 1/3. That became the slope in the new line. We plugged in the point that the new line passed through to get the y, the x and the y values established. So now we know that b, or the y-intercept, is 5. Plugged it in, wrote it in function notation. Any questions on this problem? All right, any other questions before we go on? Now is the time, because once we go on, we're not going back because I got to open up a bunch of different screens and things. Okay, here we go. So let's see here. We're going to close this up and open up this screen. Give me just a minute here. Okay, so stop sharing and all right. So can you see on your board there, it says 17a f of negative 2. Can everybody see that? Can at least one person tell me that?
Yes. Yes.
Thank you. Thank you. I knew I wasn't the only person alive this morning. At least I was hoping not. Okay. So over on the right, we have a graph of f. It's a straight line, so it's a linear function. And what we're going to be doing here is identifying ordered pairs, but using function notation, okay? So 17a says f of negative 2. And the directions say refer to the given graph to find each value, okay? So f of negative 2, basically that's like saying we have the following ordered pair, which is -2 comma something, okay? -2 comma something. So the question is, what is the corresponding y value when x is -2? So going over to the graph, x equals -2 would be, let's see here, let's switch colors to highlight it. So let's go with red. X equals -2 is right there. So right here is the point with an x value, oops, a little bit off there, an x value of -2. So what is the corresponding y value to that point? It is -4. Okay, so f of -2 is -4. That's saying, that's the shorthand notation for saying, look at the graph, find out where x is -2 on the graph, what's the corresponding y value? So f of -2 equals -4. Any questions about that problem? Okay. Next question says find f of 0. So basically what we're doing is we're completing that ordered pair. On the graph, find out where x is 0. What's the corresponding y value? It's also 0. This graph goes through the origin. So for this graph, f of -2 equals -4, f of 0 equals 0. Any questions about this? All right. So for the first two problems, it was a case of given the input, find the output. For part C, it says the value of x for which f of x equals 4. So now it's a case of given the output, what is the input? So we need to find on the graph a point that has a y value of 4. Well, y equals 4 is right there. The corresponding x value is 2. Any questions on that problem? Okay. Part D says the value of x for which f of x equals -2. What's the input that causes an output of -2? Where is y equal to -2? Right here. Oh, x is -1. That doesn't show up very well. So really all we're doing here is completing ordered pairs. We're saying for this graph, when x is -2, y is -4. When x is 0, y is 0. For this graph, when y is 4, x is 2. When y is -2, x is -1. Again, if you have any questions about this problem, now is the time to ask, because this is very basic in what we're going to be doing the rest of the day. Okay, let's go to the next page. Basically the same question or questions, okay? Except now we have the function s, and it's no longer linear. 18a, s of -3. So what do I want to do? I want to find the corresponding output when the input is -3. Well, here's -3. So when the input is -3, the output is 2. Take a look at s of 3. When the input is 3, the output is 4. We okay with that? I guess I'll just assume we are, unless somebody says something. Okay. Now, part C says the values of x for which s of x is 0. On the previous problem, it just said the value. Now it says the values. So apparently there's more than one x value that has the same y value, Remember, that's okay with a function. Multiple inputs can go to the same output. You just can't have one input going to multiple outputs. So S of x equals 0. That's basically what? Y equals 0. So we're completing the following. Where does y equal 0? Well, that's along the x-axis. So here, here, and here. So there's 3 x values. X equals -1, 1, and 5, which would correspond to -1, 0, 1, 0, 5, 0. And you don't need to write this. I'm just trying to show you their equivalent. So these are the x values. Those inputs produce that output. All right. Part D, the values of x for which S of x equals 3. So now we're looking to complete this kind of ordered pair. Where does y equal 3? Right here and here. So x is what? 2 and 4. 2 and 4. So we'd say when x equals 2 and 4. So far, so good. Okay. And if I'm going too fast, if I need to slow down or go back, please tell me. All right, let's see here. Same kind of idea that we just did. Okay. Except now the function is g, or g of x. So g of -2. So we're looking to complete. I don't know why it does that, but it does. Okay. So we're trying to complete the following ordered pair. When the input is -2, the output is 2. When the input is 0, the output is 2. Oh, so there's a case where 2 different inputs go to the same output. That's okay. That's still a function. All right. Now, the value of x for which g of x equals 3. So basically, we're looking to complete this. And notice it says value. So apparently there's only one. Y equals 3 is right here. X is -1. So this would be x equals -1. So all we're doing is given an x, find a y, given a y, find an x corresponding to the graph. Part D says the values of x for which g of x is -1. Oh, so now we're looking to do this. G of x is -1 here. So that would be at what? -3. And here, which is at 1. So x equals -3 and 1. Questions there? All right. This one says, find the domain and range of f. So we have this linear function here, f. Okay. Now, this arrow means that this thing keeps going up. Notice as it's going up, it's also going over. This arrow means it's going down. As it's going down, it's also going over. So the domain, since this thing goes on and on forever in both directions, the domain would be all real numbers. Now, we never put a bracket around negative or positive infinity because that would imply that there's a specific endpoint. And negative infinity and positive infinity is the idea that you just keep going on and on, kind of like I do, okay? That there's no endpoint. So this function would graph all real numbers in terms of input or domain. Likewise, the range, this goes on up, this goes down. So the range would be all real numbers as well. So the domain and the range are all real numbers. Any questions there? Okay. Let's see here. Again, find the domain and range of f. The domain, well, as this is going up, it's going over. As this is going up, it's going over. So it's going to cover all real numbers from negative infinity to positive infinity. However, the range, the lowest value of the range, y equals 3. And from there, it goes up. So it would be a bracket at 3, and then infinity and parentheses. Okay? So the range is everything above and including 3, or greater than or equal to 3. Questions there? All right, we'll keep going. Find the domain and range of f. Same idea. Now, this is going over and down, right? But it stops right there. So the domain starts at 0 and goes to positive infinity. So it'd be all real numbers greater than or equal to 0. The range is going down here, but we list domain from smallest to largest. We list range from smallest to largest. So domain goes from left to right. Range goes from down to up, so to speak. So the range goes from negative infinity up to 0. Okay. So the domain is this, and the range is, well, that, but it stops at 0. Okay. So it goes from negative infinity all the way up to, but stopping at 0. Again, any questions about the interval notation there? Okay. Now they kind of take the two ideas and put them together, finding ordered pairs and finding domain and range. So this is the function f, but be careful. Notice the scale. On the x-axis, the scale, each square is 1 unit. On the y-axis, each square is 5 units. Okay, so be careful. So f of 1 would be 15. The x value is 1, but the corresponding y value is 15, right? Because you got 5, 10, 15, 20, 25. Okay. F of negative 3 would be 5. Find the values of x for which f of x is 0. F of x is 0 would be right here and here and here. So the x values would be, let's see, that's negative 3. Oh, no, that's negative 4, isn't it? Okay. So negative 4, and then negative 2, and then 0. So those are the x values that have a y value of 0. The domain and range of f. Well, again, this thing's going up and over, this thing's going down and over. So the domain, all real numbers, the range, all real numbers as well. Okay. Pretty much same thing again. Find g of 1. Now the scale's back to each square is 1 unit on the x-axis and 1 unit on the y-axis. So g of 1 would be 2. G of negative 4 would be negative 5. Okay. The values of x for which g of x equals 4. Oh, that would be here and here. So that would be what? Negative 2 and positive 2. X equals negative 2 and positive 2. the domain and range of G. Okay, as this is going down, it's also going over. As this is going down, it's also going over. So the domain is all real numbers. The range, however, goes all the way down to negative infinity, but the highest value of the range is 4, corresponding to these points there. It's awfully quiet. I hope you guys are getting this. Okay. 72, new directions. It says this. Determine whether each graph is the graph of a function. If it is not, find two ordered pairs where more than one value of y corresponds to a single value of x. Okay, so we're going to use something called the vertical line test. Vertical lines, okay? So vertical lines would be like these, okay? If we can go to the graph and draw a vertical line that passes through the graph more than once. So if a single vertical line passes through the graph more than once. So for instance, how about here? Yeah, that one does. That one does. Okay, here, this one does. That represents an x value going to two y values. So for instance, when x is 6, y takes on this value and this value, okay, which is what, a little more than 5, a little less than -5. When x is 4 point something, y takes on. Well, anyway, let's take a look right here. Okay, I deliberately drew those where it was nice to identify. So this is not a function because it fails the vertical line test. So we're going to list two ordered pairs where you have the same x value going to two different y values. When x is 1, y is 2. When x is 1, y is -2. So that violates the idea of a function. So we're using the vertical line test. If anywhere on the graph we can draw a vertical line and that line passes through more than one point on the graph, that represents an x value having more than one y value, therefore not a function. Okay, and there are lots of different answers you could give for the two ordered pairs. I just chose two that were easy to identify. Okay. Same question again. What was it? Determine whether each graph is a graph of a function. If it is not, find two ordered pairs where more than one value of x corresponds to a single value of y. Okay, now, the open circles means that there's no point there. The filled circles means that there is a point there. So if we go across this thing and we draw vertical lines, for instance, here, that doesn't cut through the graph more than once, because down here, that point is not on the graph. That open circle represents that it's not there. Same thing here. So yes, this is a function. Suppose that this point right here was filled in, then it would not be a function, okay? All right. Same thing here. See if this is a function. If it is, say yes. If it isn't, say no, and give two ordered pairs that show how it violates the idea of a function. How about right there? So not a function. So a circle is not a function. Let's see. 3, -2 and 3, -6. 3, -2, 3, So there's two ordered pairs that have the same input going to two different outputs. Therefore, it's not a function. All right. Well, that's all I've got for you today. So basically, you're going to be looking at graphs and figuring out what the coordinates of the points are on that graph based on the information given. I will be back this afternoon at 1:15 for an office hour. So your homework tonight is section 8.3. Have a great rest of the day. And I'm going to go ahead and stop the recording.